All right, so we're going to go over one of the things that you may or may not encounter on the AP. I can't promise that you'll be assessed on this, although I can't really promise you assessed on anything. I kind of pick and choose. Anyways, side note, this is what happens if you're given an acceleration time graph and you have to create the velocity time graph and the position time graphs. All right, now I put numbers on this, so that way not only are you actually sketching it, but you're drawing it. Because remember the difference between sketching and drawing is sketch is just shapes, drawing has numbers. So let's get some pens in the order here. So the big idea that we're going to remember here is the area of a VT graph is your change in velocity. Why did I put VT graph? Oh, AT graph, sorry. Doing this for a few times. So your area of your acceleration time graph is your change in velocity. So just as I did with the VT graph, because area of VT graph is displacement. So that's how you go from here to here. And then we'll just write the other one down here because we'll run into that as well. The area of your VT graph is your displacement. So that's how we're basically going to go up here using areas. So to do that first one, let's go back to our color red. I like to kind of shade this in a bit here. Get all these areas. Remember, it's okay to have positive or negative. So this first one, this first area, obviously we've got some zeros going on here. But this first one, we've got a positive 3 times 2, so that's a change of 6 meters per second. And then this other one, we have a change of negative 6. And obviously you'd have to be given an initial velocity because all this tells you are changes. But we're just going to assume our initial velocity is 0. But you could technically be given, hey, the initial velocity is 3, and then you just start at 3 and you'd go from those with your changes. So for the first 2 seconds, we see absolutely no change in our velocity. All right, so whatever our velocity is, it is constant. All right, so if I said my initial velocity was 0, then it would just be a flat line of 0. If I had it being starting at positive, it would just be a flat line of that. Then I have a change of positive 6. So I'm up here to now a velocity of 6 since I started at 0. And so that is a nice constant slope. And so then here I have a change of 0. So now you'll notice that I'm just going to again go flat because I have no change. Whatever my velocity was, it maintains that. And then finally we have a change of negative 6. So I lose that. And then I'm back to where I started. Okay? So it's going to have this shape. Again, if you were given a different starting velocity, even like a negative something, you could have this shape be moved up or down, but it would maintain this exact shape. So now, if we wanted to go to the other piece, which is creating a velocity time graph, which I'm going to go purple. I love purple. All right. Again, the area of this velocity time graph is our displacement, so we're going to use that as our standing point. And again, you could be given any position to start with, but we're just going to start with zeros to make our life kind of easy. So our initial velocity is 0, so our change in position, because there's no area here, is 0. So we're basically just a flat line. But now things get interesting because if we look, we've got these different segments for area. So this is each of these lines is every 2 seconds. So our first is 6 times 2, but you got to divide that by 2 because triangles, they're real. So we have a change of 6 meters. And then over here, we're going to have 6 times 2, so that's a change of 12. And then here we have another change of 6. So if I go along this, let's see if I make sure I get this right. We're going to have 6, 12, 18, 24. All right, so the first time we only had a change of 6. I'm just going to put my dots here. I don't like to fill it out until afterwards. So then I got 12 more. Remember, these are changes. So we're going to end up going up to 18 for our next one. So about yay-ish. And then we're going to go up 6 more. So we're going to end up at 24 for our last one here. And it's going to be about there. So now that we have our dots in place, why did you disappear on me? Now that we have our dots in place, we have to make sure we have the right shapes. So here, my velocity is increasing, because remember, the slope or the derivative of the position time graph, is velocity. So here I have a velocity that's increasing, so that means up here I have to have a slope that's increasing. All right, and they're all positive, so they're all positive slopes. So we're going to see ourselves start to turn upwards here. So I have the upwards curve. Then my velocity is constant and positive. So this should then be a single line because I have one velocity. Therefore, I should only have one slope. They're both positive, so both are positive lines, positive slopes. Then over here, my velocity is approaching 0, so my slope has to approach 0, so I'm going to start to flatten out. And again, these should be nice, smooth transitions. It should not look like curve, line, curve, okay? You should not have these points. There should not be sharp edges, okay? So make sure you do your best to not... Whoa, no! What just happened? All the things. Oh, no, we lost everything. This is where I start to cry. There we go. Everything just disappeared on me. The downfall of doing many things on one slide. Sorry about that, guys. Welcome to reality. Alright. Life doesn't always work out the way you want. So we'll just erase that. Alright, so you want to make sure it's nice, smooth transition, no jagged edges. And then the last part, we don't want to forget that last part. Here we have, yeah, I got it. We have a constant velocity of 0, so that means our position is not going to change. And so we're going to flatten out. But again, notice I don't have any sharp transitions. I go from here where I have a curve. Here I have a line. Here I have a curve. And again, if you draw a picture like, I can't even tell if I drew a clear distinction. I would recommend you can make some notations like this, and the graders will be like, oh, this kid clearly knows what they're talking about, so it's good to go. So again, main idea, area of a acceleration time graph is change in velocity. It's not velocity, it's the change in velocity. And then that allows you to make your VT graph. And then once you do that, area of a VT graph is your displacement, which is your change in position. And then you put your points up here on the position time graph. And then once you have your points, you just got to draw the right shapes. And that's based on the understanding between the slope of the position time graph and what the actual velocities are. So, awesome. Went well for me, except for the giant hiccup where the computer hated me. But hopefully that made sense to you. And if you have any questions, you guys know where to find me. It's been fun. See you next time.